Yes. Yeah, good evening, all. So, myself, I'm Vijay. Like, I hold 20 plus years of experience in various technologies like Informatica, Big Data, Hadoop, Spark, and this data engineering, like Azure Data Engineer, right? So, before I start, can anyone please confirm whether my voice is clear, whether my screen is visible or not? Yes.
Yes, voice is clear. Okay.
Fine. Thank you. So, cloud. It is majorly utilized for right storing, analyzing, storing, analyzing, and delivering data in various forms. So cloud is majorly utilized for storing, analyzing, and delivering data in various forms. So data engineers with this help of cloud services work on the data and make it structured. So data engineers, right? With the help of cloud services, work on the data. They work on the data and make it structured and useful. Right. So talking about advantage, okay, we talk about on-premise databases. On-premise databases. We need to set up. We need to set up our own hardware infrastructure, and later on top of it, OS installation. On top of that OS installation, and later purchasing purchasing database license. Database license. Next, installation of database server and designing database objects. Designing database objects. We need to set up our own hardware infrastructure. On top of that, OS installation, purchasing database license, installation of database server, and designing the database objects. So to maintain all this, we require separate teams. We require separate teams. Hardware team, operating system team, networking team, security team, and database administrators. Database administrators. hardware team, operating system team, networking team, security team, database administrators. But everything in the, but here everything in the cloud premises, but everything in the cloud premises. No need to maintain all this. No need to maintain all this. No need to maintain any infrastructure. No need to maintain any, no need to have any licenses here. Everything in the cloud environment, right? Everything in the cloud environment. Yes. So data engineers, with the help of cloud services, they work on the data and make it right. Data engineers, right? Are responsible. Data engineers are responsible for smooth data flow, data flow from source to destination, right? From source to destination. Data engineers are responsible for smooth data flow from source to destination, right? So data engineer. Data engineer is responsible in preparing the data, cleansing data, filtering data, cleansing the data, transforming the data, process the data, right? Preparing the data, cleansing data, transforming data, and processing the data. You see, most of them will be asking the difference between this data engineer, data scientist, and analyst, right? Data scientist. Data engineer, data scientist, data analyst. Data scientist strategizes for the future. Strategizes for the data scientist. Is okay. Data analyst summarizes the past. Data scientist analyze data. You're going to analyze data, identify the patterns, recommendations for the future. Recommendations for the future. Data analyst summarizes the past. He is also going to analyze the data. Summarize the data of the past. Summarize the data of the past. Visualizing the data. Next is what? Visualizing the data. Summarizing the past, analyzing the data, summarize the data of the past, and visualizing the data. So data engineering, preparing data, cleansing and transforming and processing. Data scientists is going to analyze and identifying the patterns and recommendations for the future. Data analyst summarizes the data of the past and visualizing there. Data engineer, data engineer does all the groundwork, does all the groundwork. He does all the groundwork for data scientist and analyst. More than, observe this, more than 80% of the data of data analysis, more than 80% of data analysis work is done by data engineers. More than 80% of data analysis work is done by data engineers. So this data engineering involves what are the sources of the data? What are the sources of the data? What are the format of the data? What is the format of the data? How to transform data? What is the destination of the data? So what is the destination of the data, right? That is target. So here, what are the sources of the data? What is the format of the data? How to transform data? What is the destination of the data, right? Target. Yes. So why Azure data engineer is demand today? Why Azure data engineer, right? So, for example, why Azure data engineer demand? Just observe that. An organization, for example, an organization, right? It wants to increase the business revenue by utilizing the customer behavioral data on its website. The organization uses Azure for its operations. So it is going to hire two people. It is going to hire two people. Azure data engineer and data scientist. First, data engineer creates a data warehouse, is going to create a data warehouse for the organization. A data warehouse is the storage of structured and queryable data. It contains data from various sources like user logs, clicks, existing customer data. Data engineer structures this data, stores it, and monitors in the data warehouse. Secondly, the data engineer communicates with the data scientist, is going to communicate with the data scientist to understand the data requirement. And also he communicates with the business team to know the business requirements of the organization. So he is to keep in mind the business needs while dealing with the data in, right? So data scientists later they analyze and create insights from the processed data. Business team requires some dashboard tools for visualizing the key insights. Right. Data engineer here, data engineer constantly keeps on processing, analyzing, and monitors the data. He creates a data pipeline. He creates a data pipeline through which the data is integrated with all the crucial stages of the data. He creates data pipelines, right? So he also makes sure that the pipeline is always efficient and secure. So this is the primary role of a Azure data engineer, right? There are many other roles. Role of Azure data engineer. Role of Azure data engineer. First thing, designing the entire data flow architecture. Designing entire data flow architecture. Secondly, creating data warehouse. Creating data warehouse. For storage of analytical data. For storage of analytical data. Designing entire data flow architecture, creating a data warehouse for storage of analytical data. And thirdly, ETL. ETL, extract, transform, and load. ETL. Extract, transform, load. ETL, extract, transform, load. The ETL process is one of the key tasks of data engineers. The ETL process is one of the key tasks of Azure, that is data engineers. They need to extract data from multiple sources. They need to extract data from multiple sources. They need to transform it into structured and queryable data, and then load this data into company storage service, and then load this data into company storage service for further business evaluations by the data scientists. Next is like data monitoring. Data monitoring. Data engineers make sure that the ETL is performed perfectly and the data is available anywhere and everywhere where it is required, right? And data security. Data security. Ensuring data security is also a major responsibility. Ensuring data security is also a major responsibility of data engineers. Data needs to be secured at each step of the process without any leaks or exposures. Collaboration and communication, right? Collaboration and communication, right? Collaboration and communication means, right, the data engineers, right, they need to constantly communicate with the business team to check the business requirements, that is the data requirements. Collaborating with the data scientists is also necessary to deliver the data as per their needs. Analytics. Data engineers analyze the data and transform it into structured and useful formats. They need to have the strong analytical knowledge, mathematical skills to perform this analysis, and also for automation. Yeah, we need to automate certain processes. We need to automate certain processes. We require minimal human interventions, right? Such as extraction, right? Yes. So these are the roles of Azure data engineer, right? Designing entire data flow architecture, creating data warehouse for storage of analytical data, extract, transform, and load. ETL is the major key task of data engineers for extracting data and making it structured, making querying on that, loading this data into companies' storage service. Data monitoring to see whether the ETL is performed perfectly as there is wherever the data is required, whether it is available or not, right? Data security, no data leaks or data exposures at each step of this process. And collaboration and communication, right? Yes. They will be constantly communicating that they will be constantly communicating with the business team. Yes, they will be constantly communicating with the business team and the data scientists. Yes, analytics once. Data engineers analyze the data and transform it, right? Making it structured and useful, and they need to have some analytical knowledge, I said, and for automation, certain process need to be automated like the extraction processes. Yes. Now, Azure data, I just to give overview about this Azure data engineering products or services. Azure data engineering products or services. Azure data engineering products or services, right? First one, Azure SQL, Azure Data Lake, Azure Synapse Analytics, Azure Data Factory, Azure Databricks, Azure Data Lake, Azure Synapse Analytics, Azure Data Factory, Azure Databricks, Azure Cosmos DB, Azure Streaming. Sorry, sorry. Hmm. Azure SQL, Azure Data Lake, Azure Synapse Analytics, Azure Data Factory, Azure Databricks, Azure Cosmos DB, Azure Streaming, Azure Key Vault, Azure Key Vault. All right. Azure SQL, right? Yes. Azure SQL is a cloud RDBMS database. Azure SQL is a cloud RDBMS database, right, of Microsoft. Azure Data Lake is a kind of distributed file system. It's a distributed file system with unlimited data storage. Already in, if you got knowledge on Hadoop, you got HDFS, but in Azure Data Lake, it is cloud DFS. Can say it's Azure Data Lake is a repository for large varieties of structured, unstructured, and semi-structured data. And Azure Synapse Analytics. I can say Azure Synapse, we have got it's a cloud RDBMS for data warehouse, for analytics, for batch processing, and for parallel processing. Azure Data Factory. Azure Data Factory is a cloud-based ETL. It's a cloud-based ETL of Microsoft in the Azure Cloud Platform. ADF, it's a data integration service. Data coming from one side and processing data comes from other side that have been transformed as per the destination. Azure Databricks. So generally data factory, right? Bringing data, pulling the data or this extracting data from different sources, from sensors, from IoT, from logs, from media files, from custom applications for business applications, right? Is extracting, right? Data and storing the data in data lake, and from data lake, data is going to be prepared. Okay. And finally, the data is given for querying, visualizing, and training. Azure Databricks, Azure Databricks, right? Very fast. It's a fast Apache Spark based data analytics platform. Azure Cosmos DB. It's similar to MongoDB, right? MongoDB, okay, it's a NoSQL database. Schemaless behavior, first record to last record, any number of fields can be maintained. But normal SQL, first record to the last record, same number of fields has to be maintained. But here, no. Sorry, Azure Cosmos DB. The NoSQL database, schemaless behavior, random access. Record to record, different number of fields we can maintain. Azure streaming means it's real-time analytics and event processing engine for analyzing and for processing high volumes of streaming data and multiple sources simultaneously. Azure streaming analytics, yes, and Azure Key Vault. Secure key management for protecting data in the cloud. Azure Key Vault, as I said, it is a kind of protecting data in the cloud. So these things I just have given overview about it, right? Azure Data Engineering project. So as a Azure Data Factory or Azure Databricks developer, as a Databricks developer or Data Factory, right? Just you are going to interact with all these products or the services. So as part of this course, right? In this course AD, right? In this AD course, right? Yes. I'll be more discussion will be on this Azure Data Factory, Azure Databricks, and Azure Synapse Analytics. And apart from that, I'll also provide knowledge on this Azure SQL, Azure Data Lake, Azure Cosmos DB, streaming, the other things also, right? So as I said, ADF developer or Databricks developer, you are going to interact with all these components, and even talk about the job market of it. I'll be briefing you about these things in the tomorrow session, more on these products. But talk about this job market, right, of Azure data engineer, right? According to the Microsoft, right? Every year, like lakhs of companies registering themselves on Azure. Means more than 95% of the Fortune 500 companies are utilizing Azure cloud services. They're in turn increasing the number of opportunities for the Azure data engineers constantly. Means the major companies are beginning the trusting this Azure, organizing shifting to Azure, organizations are shifting to Azure, and already they are utilizing it regularly. Needs of professionals who can work with Azure and handle this big data, right? Huge data. According to the pay scales, according to the pay scales also, right? According to the pay scale, data engineers have got the highest average salary as closely as data scientists. According to the survey, to the top two highest paying jobs, data engineer, data scientists. So pursuing a career in this data engineering, that's what is the course content I'm going to discuss. What is that? So ADF, lot of things like it's a zero coding ETL. I can say ADF. It is a zero coding ETL. Here, overview about all the resources. Azure Data Factory, Azure Data Factory architecture, Data Factory, portal UI, top level components, pipelines, activities, linker services, data sets, triggers, data flows, and integration runtimes. Pipeline, creating a new pipeline, organizing the pipelines under folders, debug pipeline, publish pipeline, parameters or pipeline parameters. Linker service, creating a linker service for blob, creating linker service for SQL database for SQL server, Azure data lake storage generation, Azure data lake generation, right? And data sets. What is data set? Creating a data set for different files, Avro file, binary files, CSV files, Excel files, JSON files, ORC, Parquet, XML, blob, activities, wait activity, variables, creating a variable, set variable, appending the variable, right? Copy data, general, source, sync, mapping, settings, user properties. Copy files from the blob container to another container. One file from a folder, all files from a folder. Copy data file from blob to SQL database. Databricks notebook, Azure the function, lookup and store procedures, get metadata, delete, execute pipeline, validating pipelines, fail, iterations, condition for each, if filter, if conditions, switch until, what is triggered, type, schedule, tumbling window, storage events, integration runtimes, Azure auto resolve integration runtime, manage virtual net, self-hosted, linked self-hosted, Git configuration, Azure DevOps, credentials, manage private endpoints, and this data flows, mapping data flow debug, transformations, group by pivot, unpivot, flatten, conditional split, exist, filter, sort, alter row, asset, flowlet, validate schema drift, remove duplicate rows, using mapping data flows in Azure Data Factory, slowly changing dimensions. Okay, type 1, type 2, ADF lot, nearly 50 exercises I'm going to discuss. Nearly 50 exercises I will be discussing with this. Create variables using set variable activity, iterating files using this loop activity, copy activity, blob to blob, copy activity, filter file formats, deleted source files and after copy activity, converting one file into another file, bulk copy data files, how to set up integration runtime, copy data from on-premise to Azure cloud, how to use schedule triggering, tumbling window trigger, event-based trigger, use the with activity, until activity. So all these things, right? And coming to Azure Databricks, will be given knowledge on big data, Hadoop, Azure cloud, and introduction to Azure, right? And introduction to Azure Databricks, creating Databricks, and adding users and groups to the users, creating a cluster from the user interface, getting started with notebooks and jobs, creating and configuring clusters, managing clusters, displaying clusters, right? Starting a cluster, terminating a cluster, deleting a cluster, cluster locks, types of clusters, all-purpose cluster, job cluster, Databricks pools. Databricks utilities, credential utilities, data utility, file system utility, library utility, secrets, widgets, limitations of utilities, Databricks integration with the blob storage, Azure Data Lake Storage, Gen 2, Azure SQL Database, Synapse, Snowflake, Databricks, how to handle multiple file formats, CSV data, JSON data, Parquet files, Excel files, XML files, ORC file format, Avro files, Databricks batch processing, historical data load, incremental data load, date transformations, aggregations, join operations, window functions, union operations, right? Databricks streaming API, handling bad records, streaming data from Gen 2, load the data into tables, Databricks Lakehouse, Delta Lake, difference between data lake and Delta Lake, introduction to Delta Lake, features of Delta Lake, how to create Delta Lake, major statements, handling SCD type 1, type 2, handling data deduplications in the Delta tables, handling streaming data in the Delta Lake, workflows in Databricks, introduction to these workflows, and Azure Synapse, introduction to overview of tools in Synapse Analytics, using Azure Synapse Analytics to query data lake, Azure Storage Account integration with Azure Synapse, Azure Synapse triggers, Azure SQL database integration with Azure Synapse, incremental load, logging and notifications, deep dive into copy activity, data flow in introduction, right? And Spark pool introduction in Azure Synapse. This is what I am going to discuss, right? A huge syllabus like Azure Data Factory, Azure Databricks, Azure Databricks, and also with the PySpark, right? With PySpark and Synapse Analytics. Apart from this, the other things like Azure SQL, Data Lake, the other things also I'm going to cover, right? Tomorrow also you can attend the session, everyone, same time at 4 p.m. using the same link to see more discussion on this, right? So a lot of jobs for this ADE, sorry, ADE like Azure Data Engineer, right? With huge packages, the package is like 1.5 times other than the other technologies, right? So it looks very simple, especially like ADF, no coding, everything drag and drop. The Databricks, you'll be seeing little bit of coding that too in Python knowledge, right? You need to have the basics of Python. The prerequisites for this is basic SQL and basic Python. Any other queries, anyone? So this just it's an introduction to this Azure Data Engineering and what are the roles of Azure Data Engineering and the comparison with other data scientist, analyst, and why this Azure Data Engineering demand today, and what are the products of Azure Data Engineering services. And I'm going to brief you more on this in the tomorrow's class on this Azure Data Engineering products, right? So if there are no other queries, I will signing off for now and meet you tomorrow same time. If you have the same link. Yes, thank you all for your time. Thank you. Meet you tomorrow.